Welcome everyone, and my name is Rod Morano. I'm co-founder of the Hackerati, and my other co-founder Jeff Scott is in the audience. And I want to welcome you to our first big data seminar. And the reason why we're here today is to kind of give you a sense of what a little bit of training from us is. We're not a training company, but we are actually delivering our training in terms of how the world looks at big data, and working together with our sponsors here at TurnToTech, as well as AWS. And unfortunately, our other sponsor couldn't make it tonight, but they are morally supportive of our cause, and Big ML. And we're here to kind of give you a sense of what is that engineering startup owner's manual to actually, how do you use big data? i.e., why should I care? And what do I need to really do to actually begin to leverage big data in our business? Who here has any experience with big data? Please raise your hand. Out of the people who have their hands raised, who actually likes their experience with big data so far? Who thinks that it could actually be better? Right. So one of the things that we're going to kind of show in this seminar format is a way to actually make it better. And why we came up with the Agile Engineering Owner's Manual on big data is that we realized, working through our clients, that there's a lot better way to actually deliver big data than has been thought of before. So we've kind of given you guys a collective look into what having a course is with us, as well as actually learning from that course, which is really based upon real world learning. That's obviously protecting the innocent. We don't give our clients' work away or tell you what we did specifically for clients, but we've collectively pulled together lessons learned, and that's going to be wind up part of our either introductory or advanced course in big data. So we wanted to work with our partners today to kind of invite you to take a peek at what we're doing internally with our training on big data. So before we actually go in to the seminar itself, I'd like to introduce our sponsors. First of all, Teddy from TurnToTech.
Hey everybody, welcome to TurnToTech, and welcome to the Hackerati team. We're excited to be part of this, and I think I'll just give you a little bit, just a little bit about what you walked into in terms of the space and what we do here, just to give you an idea. TurnToTech is a software school. We teach mobile. We teach web development, mobile development. We're about to announce a data science curriculum, which we're really excited about. And we have intensive boot camps. We also do part-time classes for people that are working. They can come after work at this hour. And we're also about to announce an online program as well that'll be online learning with live help. So it's a little different than traditional online learning. There'll be live help as part of it. And we just love our relationship with the Hackerati team. Rob, Fred, Derby, and the rest of the team here, we're excited to be part of this with them. They're actually an important hiring partner to us. They've hired some of our students, and that's a really big deal to us, because for us to have our students work at a place where their career is flourishing is a really big deal. And the people that have been working at Hackerati, they're pretty psyched about their career. So I thank you for the opportunity to work with you guys. And I think that's it. If you have any questions about anything, I'm Teddy at TurnToTech.io is my email address. I'll be around after if you have any questions, and I'll get out of the way. Thank you very much.
Thank you, Teddy.
Okay.
My AWS friends, come on up. John? And what we'll do is we'll first kind of give you a podium to kind of introduce where you are, and then after we actually get through the first part of this, then you can kick into the presentation portion.
Okay.
So the floor is yours for intro.
All right, thanks. So my name is John Laughlin. I'm with Amazon Web Services. You'll see we're sponsoring some credits. We're also offering quite a lot of tools that will make your exploration of big data, we think, a whole lot easier. Easier because you'll be able to get the infrastructure piece out of the way and then focus on delivering your applications. So Beyond that, we're happy to work with you with that. We've got a special startup team that I'm not a part of, I can't really articulate, but if you've got questions, we've got answers for that. And beyond that,
Okay. You want to come up and introduce the startup team? I think that's
Wanna do that?
one of the great things here is that the Hackerati actually brought on board TurnToTech as one of AWS's startup members. So I want you guys also to hear about this program as well. Thank you.
Sure.
No problem.
Hi, everybody. I'm John Mancuso, another Amazon John, I guess. I'm part of the Startup Solutions Architecture team. Here to give, our team works with startups of all sizes. Basically, the idea is if you can join our Activate program, which is we give support, sometimes credits. We enable virtual office hours, so you're able to reach out to an architect like myself and have discussions about big data, about architecture in general, whatever it is that's maybe hindering your your development of your startup. We're able to help you with that from a technical perspective in the virtual office hour sessions. We also work extensively with accelerators, incubators, and VC partners to help. Give again any kind of technical advice to startups. So really happy to be here with Hackerati and worked with them pretty extensively in the past and some of our customers, and really look forward to learning a little bit about big data myself today.
Thanks, John. And also, by the way, you have one of our new AWS Activate partners out in the audience. I'll introduce to him later. All right, thank you. And our other sponsor, Big ML, wasn't able to physically be present here. They're here spiritually and through their presence. And they are one of the fast up and coming machine learning as a service, actually built on top of AWS. And they also allow organizations to deploy them privately into their own organizations, into their own data centers as well. And just think about what you can do with any type of service right now, for example, like GitHub, for example, what you can do with, help me out here, my engineers. I'm drawing a blank on what other types of services you have out there. You can, pardon me? You can do infrastructure as a service. You can actually do some, if you use Salesforce.com as a software as a service, you can do the same thing now with a programmable, upgradable machine learning as a service as well. So they are one of the first pioneers. There's about 4 or 5 other players in this space, and we've actually looked at their technology, kicked the tires. We don't align with any particular technology company, but I can tell you one thing: they came out with high marks after we looked at their under the hood. So thanks to all our sponsors. We wouldn't have been able to do this today without them. And the fourth estate here, in terms of the fourth sponsor, is you guys. Thanks for coming today. And I want to introduce you now to our course. But prior to do that, you're here underneath the Hackerati Academy's seminar. Hackerati Academy is an organization that sits underneath the Hackerati, which is an umbrella organization that focuses on one thing and one thing only. It's what we call engineering as a service. What software as a service and infrastructure as a service and platform as a service does for technology, we actually do for human labor. And basically you turn on, turn up, turn down, turn off our engineers based on your projects that you need as clients. So we've actually created the Hackerati Academy as a training organization for our new recruits to actually get up to speed and with boot camp. And in conjunction with our partners like TurnToTech, we ensure that the training actually goes forward without a hitch. And we want to make sure that you guys understand that our reason for living as the Hackerati is to deliver the best talent out there in order to deliver our services for our clients. And we have clients that are in the Fortune 250, do a lot of media analytics. We actually work on some heavy-duty engineering projects at all layers of the ISO stack. So if you would like to know anything more about the Hackerati, Derby is here. Is he? Where is he? There he is. There's Derby, our head of talent. And he'll be able to answer any specific questions. And also, please see my co-founder and partner, Jeff Scott. He's done a great thing with teaming up with me to create this great company. And if you talk to our employees, all Hackerati, raise your hands. If you ever want to know anything about us, please see us. So without further ado, let me begin by saying thank you to Dr. Fred Fontaine. He's actually the head of our academy, and he's also the head of electrical engineering, computer engineering at the Cooper Union, one of the top 3 engineering schools in the country. So he's, we're worthy of having him join us and head our academy. So, why in the world are we here? Well, we're here to help you guys get an understanding and taking a peek under the hood on how we train and develop our engineers, and specifically in the area of big data. We want you to also walk away with something useful. And what that basically means is this is not something that's an advertisement for us. It's not an advertisement for AWS or Big ML or TurnToTech. This is us collaborating together to give value back to you, the community, the development community, so that you can actually understand that there is some major value from each one of our organizations. So something useful that you will walk away with today, and I guarantee you will, is something how do you spin up some big data very quickly, if you know Python, and be able to actually deliver something that is useful. For example, like a recommendation system, and not understanding the details, or as Fred talks about, the real guts of the engineering. This is about putting the system together in such a way that you can get a result out based upon all the data that you've kept. So we're going to be using one of Spark Summit's training platforms to actually demonstrate this. And this is part and parcel, and but a shadow of the courses that we actually provide internally to our team members, and in conjunction with our partners like TurnToTech. And lastly, is if this is something that you want to pursue, we're asking you to answer that question in the anonymous survey, and also you have our email address, and before you guys leave, I'll give you my card, or you take Derby's card, find out more about us or Fred's details, and we'll give you more information about the types of courses that we work in conjunction with our partner. So, again, we're giving you a developer's peek into quickly ramping up some big data, processing specifically. So it's how we believe the development of big data systems is made better, or as we say internally, the right way of doing it, by using an agile approach to delivering the needs for the requirements of something that's big data. Usually what big data winds up being is I have all this big stuff. I've got terabytes of log files. I have terabytes of structured information. And I just need to know some aggregate information very quickly using an infrastructure that I can't afford ever to build. But because of the on-demand nature of AWS, we're able to very quickly gain access to very high-powered engineering equipment, if you will, and deliver that end result. And today what you're going to look up doing is you're going to stand up quickly a very simple but effective big data scalable infrastructure called Spark clusters. We're going to do very simple machine learning, and I'll let Derek and Ethan lead you through this. And then ultimately at the very end, you're going to be able to show some quick results. We tie, if you will, at the genetic level for engineering, how to come up to speed on a new technology with a method of work, which is considered agile, the agile methodology. So if you are, is anyone familiar with Steve Blank's work on customer development and pivoting? Do you all know what the word pivot means in our world? So what we're doing here at the customer level, or at the business level, you are constantly looking at how to test, come up with, quantify, test, and pivot on business decisions. Some of those business decisions, especially in technology companies, either new ones or existing ones, are directly tied to technology. Well, if you can actually allow the business requirements to be quickly tied to engineering requirements and be able to pivot very quickly, we're then able to actually deliver to the business a much more quick and effective means of determining if the decision we decided to go in this direction is the right one. And usually you need technology to do that. So what we're saying is we tie together any engineering topic that we're trying to learn, and we tie it together in an agile way. We like to work in teams. So tonight we're going to be asking you to split off into small groups to do the work that Derek and Ethan are going to work you towards. So at the highest level of a startup, you're using pivoting. At the engineering level, you're also using pivoting. And in order to actually deliver an effective means of pivoting, you have to have an effective means of doing work in a group. And we tie together Agile with that. So we take a tack of Agile-based big data engineering. And you might say, yes, so what? So I'm here to talk about and learn a little bit more about the technicalese of big data. Yes, you're going to get some of that. But you're also going to get how we think about our projects and how we've delivered it in our clients. And the way we do that is when you take on new work, you don't have to do this big design up front. Remember the old waterfall days? That doesn't truly scale. It may work for putting a person onto Mars over time. Imagine pivoting going to Mars at the engineering level. It might not be effective. I don't know. I haven't been in a space program in 20 years. But I can tell you in software, things change very quickly as you're learning. So your big design that you could have done gets broken down into smaller pieces. And the majority of you, I bet, understand Agile. We're just asking you to don't check it at the door. Use it to learn something new. And that's how we actually deliver our training internally. So again, it's about an efficient work method. It's about a topic that you want to come up to speed. You can replace the word topic with business result. And at the very end, you want to be flexible for you, the engineering team, and for the business to actually see if there's a pivot required. So let me take aside from that and give you a high level on, do we really know what big data is? Is a 300 gigabyte database that grows at 1 gigabyte a day big data? Anybody?
Whatever it is you call it, whatever big data is to you is big data.
This is not big data. How about 300 terabytes a month growing at probably a terabyte and a half less than in a day? Is that big data? Yeah. We've worked on that type of project. We've worked on smaller and bigger. And the key here is we've learned a lot doing that. There's the real-time growth aspect, right? And then how do you use in real time? How do I actually deliver intelligence to my business analysts as all this data is growing and changing? What's the architecture for that? How about this? How about I don't need it in real time? I need near real time. I need maybe an hourly rate. Would that possibly change the type of architecture you choose to build your system? It does. It changes it because I can do something cost effectively with batch. But batch not might be good if you're going towards hourly or less than hourly data. You might have to go to a real-time approach. And there's a balance between both of them. These are the kind of topics that we actually approach and into our advanced big data architecture course. But big data is on the order of hundreds of terabytes to multiples of petabytes. Another way of looking at big data in an architecture view from us, the engineering, looks at how do we ingest data. That's a very important part. You can see the ingestion part moves into real-time streams, as well as batch processing, pulling in data from ETL. And timeliness in the time series is important to understand how well and how frequently we have to ingest the data. Once you get the data put into some sort of data structure, you can then store it somewhere and then allow other portions of your processing to gain access to that data. These are important determinations you need to make as an engineer for an architecture level is, did I get the first part right? Am I dealing with only real time? Or am I only dealing with batch? Or am I dealing with a combination of both? Can anyone tell me where the real determining factor comes in there? If you use one or the other, and that's a disjunctive or, not a mutually exclusive or. What requirements come in to tell you that? Kind of made a hint of it before. It's the requirements who's going to consume the data. So if you have a business analyst team that's doing web analytics for a major publishing site, and they are an editor, and they're looking at their topic that they're in charge of. And there seems to be a surge of activity in that particular topic in that particular time. You think you need batch, or you think you need real time there for them to maximize their web analytics, to maximize ultimately their readership, eyeballs on it, uniques, as well as providing the opportunity to monetize it using advertising. Real time. What happens if it's sort of back page or front page news site? You think you might need to be batch there, or is it going to wind up being real time? Or maybe both? It may be a little both, but mostly batch. So these decisions come from the business consumer of this data that we're in charge of building the plumbing and putting together an intelligence platform on it. So these decisions aren't light decisions. You make the wrong decision and go with the wrong technology, you're backtracking. So again, we're here to kind of give you a sense of what it's like to learn from how we built things in the past in this area, to learn to build your own using the right requirements and the right interpretation of the requirements. So what I want you to plant in your head is, you're going to see a little bit today of data visualization in the area of simple text output. You're going to have unstructured data coming in, not in real time, it's coming in as batch. Because what are we doing again? What's our project?
Movie recommendations.
Movie recommendations. Something really simple, but it is an unsupervised learning example that uses big data to crunch the numbers. So those are the two areas I want you to think about. Data visualization of just simply a text file, and then input of unstructured data in a batch mode. So all of a sudden your mind, from a business, a big data architect perspective, is very focused. So what are my tools? What are my algorithms? What am I going to do to quickly ramp this up? I want to get you lost in the sea very quickly and pluck you right out. This is just a shadow of what all the choices we have as technologists to implement something that is big data related in terms of processing. That's a lot. We like to start from foundational understanding of where our data is, and foundationally, what do the requirements allow us to do? They dictate the architecture. Once the architecture is dictated, all else falls away. It makes it much, much easier to develop and to maintain. And one of the things I'll leave you before we move actually into John to present, and then we move into here, is that you got to understand that this is changing. Everyone's building their own technologies. You look at Hortonworks, you look at Cloudera, great resources in terms of delivery of big data tools. There's also a MapR, and they're coming up with a disjunctive choice of very similar technologies. And I'll give you an example. Data storage. What do you got? You got Hive, which I would say you should usually stay away from, and some of you will agree with me. Cassandra. There's a new one from Cloudera, which has been open source, as Impala. There's a lot of choices. You have to look at them all and understand what is the nature of your data. Is there a lot more reads, a lot more writes, etc. So we're going to focus in on large file, scalable processing, and real results in the area of, we're going to use S3, Spark, on the AWS, and text files, all to show you a heavily big data sourced project for music recommendations. So without further ado, John, come on up. Great.
Great, so let me start. I focus on, as an architect, on big data issues for AWS here in New York City. And I'll talk a little bit about how you run or how we address big data issues using the AWS stack. The first thing I want to talk about, though, is the idea of a managed service. Now, you've probably heard something about AWS. You probably have the concept of, we have the idea that you can run a virtual image of a Linux machine or a Windows machine in the cloud. That's nice, and that pretty much gives you the ability to go in and do whatever you want. It also burdens you with the responsibility of doing a whole lot of stuff to get anything done. Another way of approaching these things is something we call a managed service. A managed service takes care of a lot of the administrative issues in accomplishing a particular task. All right. If you run a managed service to run, say, a SQL Server or MySQL database, that means we stand it up for you. We do the provisioning, the configuration, we patch the servers, we patch the software, we do the backups. All the grunt work is taken care of. We have a similar offering in the big data space that we call Elastic MapReduce. All right, this is the managed service that's relevant in the big data space. With Elastic MapReduce, we will stand up clusters for you. You describe what you want, we will go and build it, and you have access to it. That means that, if you're interested in Spark and you go and look on the, it's an official Apache project now. They've got quite a lot of documentation, and they've got several conferences, and you can hear them say things like, well, it takes so many months to stand up the infrastructure for this. You'll have a different experience if you use AWS with EMR, okay? So we make operationally, it's much easier to stand something up and get busy doing your own work. We also make it easy to tune the clusters you have, right? If you go and you're going to buy infrastructure for this, you need to know what your requirements are up front. There are a lot of problems in the world that are going to be a whole lot easier if you're omniscient, but that's not very practical, all right? So what we allow you to do is learn as you go along and adjust what your capacity is, adjust what your infrastructure is to meet those requirements, with a fair amount of agility, with the agility that you wouldn't have unless you bought to, your peak projections and incurred all the costs up front. You can also adjust your requirements down, right? Through, if there's a bulge in your processing, you can ramp up your capacity and then pull it back down when you don't need it. This is useful when you're doing training. Right? Stand things up while your students are there, shut them off when you don't. So MapReduce will help you with that. Elastic MapReduce will help you with that. It'll help you with a variety of different data stores. We'll talk tonight about pulling data in from something called Amazon S3. That's a simple storage service. It's the ability to store a vast amount of information with a great deal of durability in the cloud, and then go ahead and access that in a variety of ways. All right, here we'll be pulling it into Spark. You have that facility there relatively easily, but you have a myriad of other ways you can pull information in. All right, within Spark, you can pull information. They integrate with Cassandra. You can run, you can pull things in from HDFS. You can pull things in from dozens of different sources for you. It's a really simple thing to do, but what you need to worry about there is simply doing it within Spark. There's not going to be a whole lot of additional burden placed on you, in terms of running it. We have a variety of other services that surround this, and I think you'll see the advantage of. But I want to tie it to something practical quickly. What I mean about setting this up is, one, you can go to a command line and do this. Visually, it's not as appealing, but intuitively, a lot of more people, I guess, are probably comfortable with that. What you can do from our console is say you want to start Elastic MapReduce and configure a cluster. You have to do things like give it a name. You can talk about, skip a slide there. You're going to get the cluster a name. You're going to pick the version of the software that you're running with. Right. Make some remarks about your security. We have the ability to hive off part of our network and you take control of it, or you can simply use what's there. All right. I don't want to dig too deeply into that in terms of what you're going to be doing in the classroom, but that's really all you're going to say there and where you want to run it. All right. Once that's done, we're going to ask you, run what? What you'll need to describe your hardware, right? And we look at a cluster as a collection of different types of nodes. There's a master node, if you're familiar with MapReduce at all. It's what controls your cluster. It's not computationally intensive, but there's a controller node. There's something called a core node. A core node will run tasks, but it also stores data. Right, so you care a little bit more about persistence there. And then there's the idea of a task node. Task node is just computational power. It accesses the data that's on the core nodes, but those resources can sort of come and go. All right, you describe how you want these to look in terms of the size of the EC2 instances that we run and the number of instances that you have. You create a user to access all this. That was clever, I called it Hadoop. When you're trying to do this on your own, and you look on the web, you'll see a nice, neat little paper saying, here's how you run Spark on EC2 using EMR. They gloss over the fact that you want the username to be Hadoop, but that's easy enough to set up. And then to run Spark, you go and you do something called a bootstrap action. Now this is just a little bit different than the rest of the stack, okay? When you run Elastic MapReduce, you're getting, oddly enough, MapReduce, you're getting HDFS. You can run Pig, which is a scripting facility. You can run Hive. You can run Impala. You can run Ganglia to see what's going on in your network. There are probably 6 or 8 tools that you get right out of the box that you put in there. You can have Hue, it's a visualization tool, and a really nice graphical way to go in and see what you've got in HDFS. All that just comes for free with the tool. And then if you want to run anything else, like IPython, like Spark, you use one of these bootstrap actions. And the bootstrap action will go in, you specify a location in S3, that durable store, object store I was telling you about. That's where the script is that'll load Hive for you, okay? You kick this off, it runs for maybe 10 minutes, right? Not months, you have to buy a whole lot of stuff up front. And what you get is the ability to go in, you can SSH into your master node and start Spark sessions there, right? So there's a scripting tool within Shell within Spark. You can have a Scala-based one, Scala-based one. You can have a Python-based one. It's really what you're comfortable with. Functionally, they're pretty much equivalent. So in terms of, I can't get too much more straightforward than that, I don't think. But what that does is it gives you the ability to get started, to be doing something. If you care about building applications or prototyping things or exploring data, you can get going here very, very quickly, right? Once you've done that, and you're learning all along the way, and you think, well, I thought this was going to be really data intensive, it's not straining the systems at all, you can go back and you can revise what you're doing. You can look at the kinds of instance types that you picked for those 3 node types, the master nodes and the task nodes and the data nodes, and you say, I can adjust, I can scale up, I can scale down. It's not CPU intensive, but it is memory intensive. I can go from one instance family to another. It's a very easy thing for you to do, right? I mean, it's not, you're not going to do it on the fly, but you can adjust these things and be back up in a very short amount of time. The other advantages to running this on AWS as a managed service is that we do all the coordination of this cluster for you. I mentioned that you could scale it, and I mentioned 3 different sort of types of servers. At a first pass, if you need more computational power, you can add more task nodes, and you can have them go away. And that's really powerful because it allows you to deal with sort of bulges in your workload, but it's also really powerful because it allows you to take advantages of some of the things that we offer that can save you lots of money. Okay. The other thing you can do is you can stand this up, you can run it persistently. Imagine that you've got an organization that queries data constantly, that runs jobs in the night, that pull information off so that people can see it in the morning. That's an easy thing to do, running MapReduce, running Hive in the background, okay? And you just have a persistent cluster for that. More exploratory analysis is facilitated by a cluster that you stand up, it's sort of purpose-built, you pull your data in, you do whatever you're going to do with it and shut it down. Stop incurring costs, okay? We can handle either of these for you, and we can do it in a way where we give you a couple of different tools to control how that costs, right? How you're going to pay for that. We have the concept of spot instances at AWS, and this is a key thing with EMR, is it makes it easy for you to put bids out on, AWS. We suspect you have this idle capacity. I'm not going to pay the on-demand price. I will give you, such and such a bid for that. You'll get that node at that price until someone bids for more. All right. Doing this with your master node, you can do it. When you lose the node, you lose your cluster. That's okay if you're that price sensitive. You can do that. very often what we see people doing is in the task nodes, the nodes that are pretty transient, where you're just adding compute power to your cluster, whether it's for EMR or Spark, MapReduce or Spark or whatever you're doing. This is a really cost-effective way. This is a way that people are saving, the claim here is 90% of the cost of those instances. So it's a very effective cost-saving mechanism. The other thing you can do is you look at your core nodes where your data resides. If you've got a consistent cluster that you're going to run all the time, you can buy these things reserved price. All right, and that can save you from, 30 to 60%, depending on the length of the reservation. So what we're talking about is a system that will take the burden of standing the infrastructure up and alleviate that by a considerable amount. Give you the ability to explore, to learn about what you're doing, and then pick and adjust your capacity as you need it. And if what you're doing is transient workloads, we've got spot pricing option with that. And if you're looking for something that's going to persist, then you get the ability to buy the reserved capacity. All right, so the idea here is to make it really easy for you to get up and running and focus on the problems you're trying to solve, which we recognize isn't running a Spark cluster, isn't running Hive, isn't running Hue. It's what you can do with that and what you can get out of your data. Right, so that's the kind of thing we're trying to make easy for you. And we do that by all the mechanisms I've described, but also integration with other services within an AWS. The key one, especially in the big data world, is S3. S3 has the capacity for you to just throw whatever amount of data at it, and you're guaranteed that it's going to be there for you. All right. So we typically see people do just that. They pull data in from their corporate data center, from whatever they're running from, they've been a farm of web servers, and they pull all their logs in. They dump it into S3. They can stand up transient clusters to analyze that relatively easily. They can do long-running things with Hive if they really want to do that. But all the cool kids are running Spark now. And the reason they're running Spark now is because it's a richer, execution engine. MapReduce has 2 tasks. You can probably guess what they're called. Spark is considerably more flexible there. Instead of having just that kind of a model, you have sort of a tree of execution steps. It also persists its data, or it represents its data in memory. So it can be considerably faster, particularly for things around machine learning, like the example you can look at tonight. Okay? Any kind of iterative process is going to be faster this way. So if you need sort of a mental map of how this might look, you pull data in from whatever source and put it into S3, and then you stand up one of the clusters I just described, and you can push it into a data warehouse, a SQL-based engine to answer queries about it. But very often, what we see people doing is standing up Spark in a transient cluster and running analysis against that. Okay, so I've included in the deck some resources on this, a couple of entries on our big data blog that will help you get started with this when you're experimenting. So if you're sitting here and you're working through that, there's a reference for copying the bootstrap action, for instance. There's a developer's guide, there are discussion forums, and there's a GitHub. Okay, so the best thing, the thing I've tried to repeat here is you need to experiment with it, right? When you're in the class, when you're working through exercises, play with it and see what you can learn.
Sean, can you take a couple of questions? Anybody have a question? I have one.
Okay. You will.
How do I set up reserved instances? What does that necessarily mean?
What that would mean,
Am I committed to a year?
typically right now, yeah, you're committed to a year or to 3 years.
Is that paid on a monthly basis?
There's a combination. You pay some money up front, and then you pay an hourly rate. Okay, but that's for every hour in this world. It's for every hour that you use it.
So if I don't use a reserved instance,
You're not
one
paying
month, I'm not paying anything for it
You're
for
not.
that month.
Well, right, because you pay some up front. There's no additional operational costs. That's right.
But you're committed for the year.
You're
So
committed for the term. Yeah.
how about if I sign up for 12 months and I only use 1 month out of that whole year? How does that work? Pardon?
That's we try and discourage people from
Okay,
doing that.
all right, that's fine.
And when you're looking at these things, use Spot all the time. If it's transient, if you don't care, take advantage of that right away. If you're going to look at buying reserved instances, don't do it in month 1. Do it in month 6. Know what you're buying know what your usage patterns are. If you think you're going to need 8 nodes, don't buy reserved instances for all of it necessarily. You can buy them on 6 and be pretty safe, right? So, you know, we're looking to make it easier, but we're not looking to have people enter into something that's going to make them unhappy. And when you're working with your sales rep, they can show you where the break-even point is for there. Right? So, in your instance, after 1 month, there's no way that you could break even. After 6, yeah, you're probably in good shape.
I'm sorry, John. I just want to point out, so what John described is actually we had a change in our reserved instance pricing model. I don't know, maybe about 2 months ago or 3 months ago. So it's actually not true anymore. Once you buy a reserved instance, you're going to pay for the hourly rate, regardless of whether or not the instance is on. The idea is to lower your total cost of ownership of the instance. So there's 3 models now. It's all upfront, where you're basically paying for the entire year. You either pay for partial upfront, where you know that's going to give you like all upfront is going to be the best deal. The second option is going to give you a pretty good deal, and then the third option is where you pay nothing upfront, but you're still committed. All 3 options pay for the entire year, basically, of usage.
Really?
So that's the change. I'm sorry.
Okay.
I just wanted to.
No, I'm really glad you brought it up. I live, typically I've had those discussions in the Redshift world where the model is very different. You pay every hour whether you're using it or not.
And that's what it sounds like, that's what the new model is.
This is
as
the
well.
new model.
Mhm.
Yes, there was. It's gone through a couple of iterations. We've had a couple of different iterations of the types of reserved instance. The one other point that I did want to bring up, though, since you mentioned about do I have to, my son, I made this cost. There is a reserved instance marketplace for EC2, so you can always sell a reserved instance, at least in the United States, on the reserved instance marketplace. If you decided that you want to run one, you can also trade it up or down as well. So within an instance family, so John showed the instance families. For example, it's a T3 instance family. We have large, extra large, 2 extra large, 4 extra large, and 8 extra large. So a large reserved instance is the equivalent. I'm sorry. 1, 2 extra large reserved instance is the equivalent of 2 larges. So if you have 2 larges, you can trade them for 1 2 extra large. Great.
Thank you.
Okay.
Any other questions, anyone? Thanks, John. I'd like to bring up Ethan and Derek, who are on our staff as our engineers in big data, and I'd like them to kind of walk you through a agile approach on learning a little bit of big data. So if you got your laptops on, you can actually follow along. The answers are given. So this is again a test for you guys to look what it's like to actually be in a course over a snapshot. And what we're going to wind up doing is we're putting together some courses that are going to run you the intro to this. So if you think this is a little bit over your head, we recommend that if you're interested, sign up for the intro course. Or if you think that this is kind of that level and you're hungry and you want to learn a little bit more, like, you know, I need an architecture that deals with a whole bunch of data that's getting sucked into S3, and then what I want to do is ramp up an EMR, do all my transient analysis, and then save the state of the actual data store, and then the next time I actually bring it up, run it again, save the store, and do it on an ad hoc transient basis. That kind of stuff would be more considered as advanced. So without further ado, and I promise you won't hear from me again until the very end, I'd like to turn it over to Ethan and Derek.
Hey, how's it going, everyone? I'm Ethan Lusterman. I've been with the Hackerati pretty much since we started. I've got a lot of experience with full stack web and big data, and I've used a lot of these tools, and I've struggled with trying to set up a Hadoop cluster from scratch. So I don't know if anyone has had that experience, but using tools like AWS and being able to stand these up very quickly definitely save a lot of time.
I'm Derek. I'll go a little later.
Okay, so basically, kind of overview of what we're going to do is kind of talk about some of the big data tools that Rob and John have already kind of explained a little bit. We're going to go into a little bit more of what machine learning actually is, what the inputs and outputs are, how you go about solving problems with machine learning, how Agile actually fits into this model, how you can kind of structure a project in this sort of sense and be able to pivot quickly, change ideas, take new inputs, outputs, data sources, what have you, and we'll actually use this to do a quick exercise on tackling a real machine learning problem like movie recommendations. It's a big thing. Netflix ran a really long competition for this and gave out very large prizes for people who came up with some of the best algorithms for recommending new movies. And so, once we introduce that problem, we'll go through some kind of hands-on. We'll have you actually spin up a Spark cluster, work with some of our data, get some AWS keys, see how the whole infrastructure works, and then try to run something and see what movies you're recommended, and then we'll wrap things up. So, like we were talking about before, big data is kind of sort of a double-edged sword. Not really a double-edged sword, but is a two kind of problem. You've got a lot of data to work with, and you need to leverage the right tools to actually do something useful with it, solve some kind of problem. In the kind of data science, machine learning kind of world, you're using data to make some kind of decision or maybe draw a conclusion. For movie recommendations, it would be some sort of decision. What movies should I recommend? Sometimes you have articles with infographics that basically will slice and aggregate, split, and summarize data, and that's where you get kind of data-driven conclusions, like 40% of people watch Netflix or something, whatever. So the first tool that kind of is the base of a lot of big data computation is Hadoop, and has been kind of talked about before. It's kind of two different problems. It's how do you store all of your data in a kind of distributed way. That's the Hadoop distributed file system, or HDFS. And then how you do computations on this data using MapReduce as the compute engine. Just a quick summary, files are stored as blocks, and you're actually processing your data on the storage. So when we kind of talked about, when we talked about the difference between Hadoop and Spark, you're actually doing an in-memory computation, and memory has a faster access on the hardware level than storage. So that's why, sometimes when you're trying to decide which tools you want to use, you might use Spark instead of Hadoop, or Hive instead of Impala, and so on. So then we have Apache Spark, and basically where we sit is we can use a Python shell, kind of wrapper around Python, or a Spark context library that allows you to take advantage of the Spark core. And then to run some of these distributed machine learning tests, we'll use the machine learning library. They also have other sorts of graph processing and SQL-like structures that sit on top of it that make it easy to run queries or do kind of graph processing.
So a little bit about machine learning and how it fits into big data. Machine learning is the general task of making a computer learn to perform something better through examples. So let's say we have these two main sorts of tasks that we do in machine learning, classification and regression. In classification, we'll be making a decision, like Ethan was talking about before. So how about we're given some pictures, and there are pictures of cats and dogs, and we need to decide if they're cats or dogs. So you get a lot of training data, and your system will learn from that and perform the task of classifying cats or dogs better. And then there's regression, which is, at its most basic form, fitting a function to lots of data. So let's say, well, numerical data. So let's say we have stocks, and we want to know how they're going to perform in the future. Well, there's a lot of information about the past, and you could try to fit something to that and guess what's going to happen. And then, yes, so machine learning, you can make computers perform some rather complicated tasks if you have enough data. That's really how this fits into big data. So let's say we have something like an application that automatically translates text for you. Here, this is a picture. We have some sign in, I believe that it's Spanish. And yes, okay, it automatically turns it into English. So if you want to make something that actually does this well, you need a model. You need to know, okay, what is the probability of a translation in English given this Spanish sentence? And then, actually this is doing a little more than that, because it's also just looking at something and figuring out what characters are written there, but ignore that for now. We're doing translation. If you want a really good model and perform anywhere near as well as humans do, you need lots of data. Keep making a more complicated model, build in grammar and all those things. Okay, so Agile. This is a very common software development methodology. It's all about being fast, flexible, and always improving. So in the manifesto, we focus on individuals and interactions and working software. So we generally break up our work into shorter, achievable goals, and we always want to be able to get something working at the end of each of those. We care about customer collaboration. The statement of work, SOW, is not really the end of everything. We have to be flexible because in software things are always changing. And yes, respond to change, as I was just saying.
So then the Agile workflow in practice, you kind of have a semi-regular set of meetings for your different cycles. And we call them sprints. And they typically range from 1 to 4 weeks depending on your team. So just for the sake of an example, I'm gonna say we have a 1-week sprint cycle. So what might happen is you kind of start with a loose statement of work. You have that kind of subdivided into different tasks that you have to kind of get through quickly to get your first release, your first kind of piece of something that actually works that you can demo for an investor or for your client. And basically that kind of starts with the sprint planning, where you have a kind of product backlog of tasks, or like we call them tickets, and you work with these tickets to define different criteria before you can close them. And the sprint plan, you'll basically have tickets that are time estimated or like value estimated in terms of the level of effort, and you'll kind of put them into a sprint. And once you have that sprint, then you can kind of start it and then begin your kind of quick agile work. And then every day when you come into work, you have a daily scrum. Some of our teams will do later in the afternoon, some right in the morning, 10 o'clock, 10:30. And basically you talk about what you did the day before, what you're gonna do today, and any kind of blockers you've been having. Is something coming up that you can't figure out? Can someone else on the team give you some assistance? And that's kind of the function of those meetings. It's a quick check-in, and then I'm gonna get started with work. Then you have grooming, which is kind of, you have a product backlog of tickets and you need to kind of maybe refine some of the requirements. You need to have not just a user story that defines a business case, but maybe you also need to add technical requirements to really illustrate the level of effort. And you'll have a grooming meeting usually once every cycle as well, where you'll give a time estimate or a point estimate, where they both loosely correspond to a time estimate. And then sort of after you complete a sprint or two, you might ask yourself, or the team might ask itself, what could we have done better? How could we move faster? How can we make sure that the client's happy? Or should we switch to 2-week sprints, 4-week sprints? So those kind of meetings fit nicely into the Agile model, and that's what we use for a lot of our teams, pretty much all of our teams, to get our work done. And then we have Trello, which is one tool that we've used that's free as a task manager. Internally and with a lot of our clients, we use Jira, but there are some costs for licensing. So for the purpose of this and a lot of our smaller projects, we'll use Trello, which will basically let you create boards which represent projects or products. And you'll kind of have cards, as they call them, which correspond to tickets. You can drag and drop them between different lists, maybe your backlog to the current sprint, to doing, to done. And from that, you can kind of collaborate with the team. It's not just, oh wait, what did he say at the stand-up? But you also have a way of communicating. You have your tickets that you can comment on, you can put links to snippets of code in GitHub, and it kind of keeps everything organized and allows you to, stay focused and really focus on delivering on a product. And then this is just an example of what the board for tonight looks like for our small task. Just to kind of illustrate the sort of different bins, we kind of dragged a few tickets into different categories. So what we would do is have everything in the backlog that kind of defines some sort of product or some sort of project. Then the to-do list would be your current sprint. You drag each ticket into doing, you can assign them to different members of your team, drag them over to done once they're done, and if you have any kind of stakeholders, they might approve it. In the context of a course, you might have an instructor approve something for you, or maybe say, this might need to be refined, let's kind of fix it.
these are the tools we're going to use in this project that we're doing. We already heard about, I think, all of these, so why don't we do some work?
So if you'd like to work individually, you can. If you would like and you don't have an Amazon account or something, feel free to break up into small teams and we'll get started.
All right, so we're going to get started. As we've been talking about, this is the task we're going to be doing. MVP, that's minimum viable product, an important concept. So our minimum viable product for now is a movie recommendation system that is going to recommend to you some movies. So yeah, we're going to take movie ratings from a lot of users. I think we have 1 million ratings or something along those lines. And we're going to use those to generate custom recommendations for you. And you're going to input some ratings for some movies. Not that many though. And we're going to use the Spark Hadoop cluster, load data onto the cluster, and use our recommendation script.
So if you haven't already joined the Trello board for this, here is the shortened link that you can go to. You won't actually be able to drag the tickets in this exercise, but you can see all the tickets, and they're labeled with different little sub-sprints or sub-tasks to basically run to get to the finished product. Also, for a more extended course, we would leave a lot of infrastructure out, and it would be you, the students' job to actually fill in those tasks and those functions. So does everyone have this link already? Can I go to the next slide? So at this point, we'll go to our Trello board and just kind of show you again the kind of workflow. Is that size good enough for everyone? Can you read that text okay? I can probably zoom. So in some Agile projects, your tickets will be sequenced as they kind of are here. We have some left out because as we were creating these, we would change numbers. Typically, most systems will increment the ticket numbers for you. In this case, we had to just kind of put them together. But the first ticket we have is sign up for AWS if you haven't already and redeem your credits using the links that we gave you. And basically, like we were talking about, tickets will have what are called acceptance criterion or criteria, and you can't close out your ticket. You can't move it from the in progress or doing column to done until you've actually finished that. So in an actual exercise with your own board and your own team's board, you would be able to drag these tickets. Just for the sake of this, just follow along with the public board and read the tickets to see what criteria you have to finish before moving on to the next step. So once you signed up for AWS, you can create an identity access management user and access keys so that you can use our Spark scripts. So kind of from here, just start following along there. And what we'll do is just kind of go, yeah, we can be around to assist you, and we'll also go through it up here. Does anyone have any questions so far?
So we're going backwards, doing to do and backwards. That's how it works.
Yeah, so you would kind of work left to right in this case.
Right to left.
Right, and yeah, in this sequence we'll just do it in numeric order. Just because some of these like some of the tickets depend on future tickets, or future tickets depend on previous ones rather. Does anyone else have any other questions right now? So yeah, if your group or you individual has any questions, just let us know and we'll come to you, or you can come up to us, and we'll kind of walk through what we've been doing already. Yeah.
I think I may have fallen off the internet.
Not the internet, just a list of things it lists to. So like, I don't think I.
Oh, you don't have the list anymore?
So are you, do you have the Trello board open?
No, I don't. I think I missed the link.
All right, we can go back to the link for anyone that still needs it. This is the shortened version if you see it over here. And these tickets have the steps kind of outlined to do everything. In like a different kind of course context, we might leave the criteria for getting things set up, or you might just have one ticket that says, set up your AWS access keys. So we kind of just wanted this to flow a little bit smoother and give you the steps to actually get this done.
How do you get to the EC2 console?
All right, so are you on, are you all signed up for Amazon at this point? Okay, so
Just wait till we get up to that?
So are you signed in to Amazon right now? Yeah, so actual dashboard is successful.
Did you get the link? Wait, still no good? You can't click any of the. Yeah, what you should be able to click it. Is that it?
Oh, okay, no, so we're right on that. Yeah, but here, we can.
It's just look at the numbers. Did you write a sound for it?
All right, so I just moved it all to one column so that you can kind of go through it.
Yeah, guys, the key here is we're talking about the public key encryption key. Asymmetric key.
Yeah, what
This guy right here, you can help me.
Have no consensus system.
Hey, so just to get a show of hands, has anyone actually gotten to the part of actually creating the Spark cluster?
We haven't accepted yet by Amazon Web Services. They said wait 24 hours. We'll be at
Okay.
Okay, who has the same problem where you have to actually wait to get your credits? All right, so why don't you do this? Why don't you, because we're going to be sharing all this stuff with you. You have it already, but we're going to actually send out the deck as well. So why don't we get Ethan and Derek to kind of pick up the pace a little so you can actually see it. The code is available. If you follow the directions they gave you, it will work.
Yeah, and we'll keep these slides public, and we could post them somewhere publicly. As
We'll
well.
email them.
Okay. So basically, what happens is you get up to the point where you are actually on the cluster.
You already put in your credentials that you got from AWS. You have a key, and then yeah, we have a script that lets you log into your cluster that you just created.
So then, when you log in with all your stuff kind of together, you now have access to this master on AWS.
So the key thing is here is the scripts that we provided you are kind of like a wrapper script around the standard EC2 scripts that come with Spark. So these are kind of driver scripts that we wanted to share with you because it kind of encapsulates everything. Because one of the key things you need to know is when you see the code on GitHub, you'll see that you need to have an access key and a secret key. You don't want to share that with anyone because that's effectively money, right? So we've actually encapsulated all that into these set of scripts that you can use to interact with the cluster. Again, something to put in your toolbox as you're using AWS. So you don't have to actually keep doing this each and every time.
Okay, so then at this point, you've got your shell. You can run jobs on the master. So you can kind of pull in data and just kind of start right away. So we have this outlined in the directions, but just to show you what they give you out of the box, the home directory has these 3 folders. And what you can do is go into Spark EC2. And if you take a little look around, you've got access to all of these tools right here. You have an ephemeral HDFS that you can load data into while you're using it. It doesn't exist after you terminate your cluster, but if you need to put data in there that's not from S3, you can do that. You also have a Spark folder, and you can do that. Okay, cool. So then basically at this point, we have this, it's ready to go. If you look in the Spark directory,
As he's pulling this up, one of the key things you'll notice when you see the scripts actually generate and create a cluster, we've actually chosen to do this with spot instances, which cost about 12.5 cents to actually get this running. So when you think about it, it's 4 nodes, you're paying 12.8 cents a minute each, an hour for each. So you can look at, this is going to wind up being under $1 an hour for you. So that actually will give you a sense of how long your credits that you got will actually last and how much spot instances work. Now these are spot instances, which means if you keep these on long enough and the rate goes above, remember what John said, they disappear on you. And you don't want your master node to actually be on a spot instance. But for practice like we're doing now, this is good enough to work with. Back to you guys.
yeah, so then at this point, you should have some kind of access to a Spark directory with a way of submitting jobs. Currently, it looks like something may have gone wrong when we provisioned the cluster. So we're going to look in.
403 forbidden error when I go to create the cluster. I don't know if that has anything to do with it.
Did you put your keys into the config file?
Yeah.
And your PEM file as well?
Yeah.
That's a good question. Do you want me to help?
Try not to.
restart it. Just destroy it. So he's going to show you now how to destroy a cluster and then create a new one. So when you destroy a cluster, you're actually disintegrating all the data that's configured on there. So don't store anything on a Spark cluster unless you move it off to S3, especially if you do it using this tool. This tool is meant for a spot instance based, ad hoc, elastic map reduced with Spark. That was it. Your data comes in and out, and comes in and goes out through S3. So sometimes, because you know this is open source software, sometimes there could be some bugs, and there had been a bug with one of these scripts before. You have to actually use the master branch for the EC2 to get it right, because there's an SSH problem in 1.2.1. Yep.
Are Spark clusters never used for storage? Is it exclusively used for processing?
Because it's all in memory.
Yeah.
So what you're doing is you're grabbing the data from HDFS or S3. They're meant for in-memory computation.
Okay.
That's why your nodes should be C class or M class, because there's a lot of memory. So when I actually do my clusters, I do C3.4x large. And basically that gives you about 32 gigabyte of RAM, and it provides about 160 gigabyte of SSD storage.
What are those called again? C3?
It's C3.4x large. Was it large? X large or large? And that actually, if you look at the scripts that will provide you, you can actually go into the configuration and just choose and write down the type of instance you want, and it'll build up the cluster like initially very easily. So pretend you don't see. Please don't copy that. I don't know where it comes from. That's the configuration file. Does anyone know Murphy? Because I think he's in here, and who invited him? No one ever heard Murphy's Law? You know, this is being edited, so this part's not being recorded, right? What changed this before? Actually, this is pretty good to run. See this up here? It's actually the instance for your main console or your master node is actually not a spot instance by design. And we chose 3 slaves, and actually you can't see the configuration of this in terms of the node type. I think master is what? Is that the C3?
C3.2 large or X large maybe?
Also use C3.2 X large.
Yeah, we could probably use like a one that's memory driven
Right.
next time.
And what's happening here is it's saying wait SSH. Anyone understand why that's happening? If you know Amazon? What's happening is because it's a spot instance, it's got to go onto the market to actually get a spot instance. So that usually takes about 5 minutes.
Well, this one's actually not a spot instance. It's
Oh, no.
Yeah, when it's a spot instance, it'll wait a few minutes to actually get the bid for that price. What this is doing actually is the instance has already been provisioned for you, but it's being kind of initialized and sort of updated. And then once it's ready to be logged into via SSH, then it'll be in the SSH ready state, and it'll install Spark and Hadoop and everything onto it. So,
Okay, so we didn't do spot instances for this one.
no.
So this is standard EC2 standard rate.
Right, and it might be
Most
like,
expensive, by the way, which is fine for this, but I just want you to know that when you're using yours, make a decision on what you're going to want to do, either reserve, or if you're going to do, depending upon your needs for requirements, you can do a spot instance. This means we're going to have to shut it down when we're not using it, because when you shut it down, you're not using any CPU compute, meaning they're charging you.
yeah, so from what John was saying earlier, kind of in light of his talk, it would definitely be better to do everything up on EMR. Spark gives you EC2 scripts to try to make it easy to, actually play with it on the terminal, kind of start it from scratch yourself. So in kind of like a further iteration of this, we would kind of go right to EMR instead of provisioning the EC2 boxes, more manually. But basically what happens is once they're all in the SSH ready state, they install a version of Spark and Hadoop on each box, which doesn't take very long. It's much, even given the hiccup that we have here, it's infinitely more time to actually try to get your own boxes and install these tools on them yourself. So even if you have some of these issues, is way better than the worst case where you have your own hardware that you need to provision this stuff on.
But also these scripts, you can start up your own EC2 instances, but these scripts actually synchronize the actual distributions to the nodes and configures them into a configured cluster. So when the cluster's up, it knows about each of the nodes. So what he's going to show you right here is how many instances are running where. So you can see all the green ones up top. Go ahead, you can explain there.
Yeah, so we have these running instances right now, and the reason why they're still in the waiting for the SSH ready state is because they're currently initializing on the status checks. And basically once those are all up and running, it'll log us into the cluster. We can copy over data, copy our jobs, clone them from GitHub, whatever, and kind of get going.
Yeah, those are C3.2x large.
Yeah, so definitely if you're kind of just one person, you should use spot instances just so that you don't rack up a huge bill at the end of the month, or you forgot to turn something off and you have to pay hundreds of dollars for AWS. I guess initially, from my personal experience, that was sort of what I was afraid of. I don't want to work with all these tools because I'm afraid I might get charged for it. But if you have the credits for it, and you know how to kind of work with the spot instances and make sure that you shut your instances down after using them, you shouldn't have any issues. I've gone a few months with a zero bill because the first year you get a lot of free instances under like a free usage tier. Like you could do like small boxes and not a lot of storage on S3, and you can do all that for free. Even some of our clients, we've been able to, manage a $0 AWS bill.
Ethan, do you recommend running on a T1 micro, or T1 medium, or T2 medium for big data?
Not for big data, no. So definitely use the spot instances for some of the larger kind of machines, and so you can kind of see, it's a little bit of trial and error. If you use a small box, you see that your job to process 100,000 rows is taking an hour. You use the wrong instance, but you can kind of stand up a larger instance very quickly, and the console makes that very helpful. And these scripts as well can be helpful, but Murphy's Law, hiccups, all that. Does anyone have any other questions while we're waiting for this to start?
I think they should be ready.
Yeah. Said they were. Yeah, they're good.
So it's going to go check.
Yeah.
Anyone using AWS right now for any of their projects? No? Yeah? What are you doing with it?
We're just running.
So basically you're doing databases. Probably some of you are using it for full stack. No one's doing big data on it?
Storing big data on it.
Storing big data on it?
For storage.
On S3, right? Well, hopefully we get this thing up and running. We can show you exactly what it looks like. Did we share the GitHub with them yet on the public side?
We didn't, but all of the scripts are up on the Trello board.
Okay, so you got the Trello board. You got the scripts on the Trello board then.
Okay, that's good.
There it goes.
Cool.
So basically what it's doing is SSHing into all of them within the context of a Python script. And then what it does is it'll kind of pull Spark from Amazon servers and actually set these up.
So it's turnkey. It installs and configures Spark and Hadoop on the nodes that you chose. It's literally all turnkey. You have to do nothing other than configure the driver scripts that you have.
Yeah, definitely like Rob was saying, with a lot of open source software, they'll sometimes notice these bugs at a time like this, and we'll patch the script by tomorrow. So, you know, if you're involved with a lot of open source stuff and you want to kind of do a lot with this, you know, you can always go to certain like repositories or different IRC chats to actually keep up with the project. So what we were looking at, for instance, you can look on Apache Spark and actually see that, you know, they have it mirrored from wherever they work on it internally. But you can see all the source code for it. You can see, you know, current pull requests that are out there. They actually have references to ticket numbers, sort of as we've indicated in our Trello board. And they have areas where you can see that, and that's kind of what you use to contribute to their open source projects if you're like remote.
I'd like to impress on you, one of the things that's a benefit of how we teach and operate within big data is we're very much command line driven. And that basically means we have to know the inner guts of what's going on. And if we know, we actually know what to go in there and fix. We either know how to fix it because we've learned how to fix it before, or we have a way to actually, and this is not special to us, this is just experience. We know exactly where to go look or who to poke to go find out how do you fix it. So, you know, there are a tremendous number of big data courses out there you can take. And I think that you should go look at them and you should take them. But one of the things that's going to be unique about how we do it is we're actually opening up the hood and getting our hands dirty internally. Yes, Murphy is in the room, but I wanted you to see this for one reason. Is because more often than not, and some of you in this room who I work with have seen this isn't easy out of the box. Not just about Spark, but just big data systems in general. And why is because it is a burgeoning new field that hasn't caught up to having 10, 15 years behind it of it being rock solid technology that literally works out of the box. 9 times out of 10, this stuff works out of the box. That one time that doesn't, you sit there like we had with the new distribution of Spark when you download it, because it hasn't caught up yet, right? The SSH bug. It's not in the distribution of 1.2.1, right? There's a problem with 1.2.1 when you do it with deployment to EC2. And you can sit there, scratch your head, you're like, this makes no sense. It's really, out of the box, I'm trying to get it to work. Why? Because it's a bug. And that's why we wanted to put together these scripts for you so the bug is not there. We fixed it. So 9 times out of 10 should work with no problem. That 1 time out of 10 or that 1 time out of 100, you're going to spend the majority of your time figuring out why. Part of our methodology in our course is to account for that time and teach you how to fish in this example. Teach you how to get around these problems.
So just in case anyone was wondering what the issue was before, we had lost internet connection while provisioning the cluster. And what happened was it didn't follow through with finishing the Spark download. So, you know, that's definitely a little bit of a fault of us, and then also the Apache script that's supposed to provision that. So if you notice here, you log onto the box using the login script, and then you have everything that you could possibly want. You've got Spark, ephemeral HDFS, and it's all kind of good to go. So then, once you get to this stage, you're logged onto the cluster, you see that you have access to these tools. You can see in the Spark folder that you have a bin where you can kind of execute things. If you want to open a Spark interpreter in Python, you basically run that script, and now you have all this. So if you look in like dir, you can see that you have SC as a Spark context. It says over here, Spark context available as SC. And you can actually interact with this to run different jobs, load different text files into memory, and run different jobs on them, import the machine learning libraries, and so on. So if you're someone who likes to actually play with the interpreter first, and then kind of write scripts later, this is definitely a great option. If you just want to hammer out all the code, you can write your Python scripts, and then just, you know, submit them, look at errors, and kind of iterate from there. So with that, so yeah, then from here, the steps that we were going to follow, basically you get the cluster up and running, and now download the data so that you can actually run the recommendation. So you also have the AWS command line tool, which should be all configured. And what you do is you can actually copy from our public S3 bucket the data, unzip it, put it into Hadoop, and kind of get going with it. So I'll run these one at a time. So of course, again, it looks like they updated AWS, so this actually does not work the way that it was kind of set. So what we'll do is actually go on to our S3 bucket. So I forget what the full URL goes to, but if you look over here, the script that we were referring to was, I don't know. Yeah, we used it, it worked.
Welcome
So-
to Murphy.
So
Again.
ML1M, if we get this link,
How big is the font?
it's really small. So now we have that using wget, and we can do an unzip.
Why don't you add that command that you did so we can look at it?
Yeah.
Can you just attach that file to the, we'll just get the W. So he'll put this on the Trello board so you can see. Oh, wait, you had it unzip, go back.
Yeah, right there.
Hit
Cool. Thanks. So now with that, and you have that unzipped, you can see that you now have this pretty folder here. Just to look at the data, we took this from the Spark Summit that has a sample of the, I think, 10 million movie reviews or 10 million movie ratings. And if you just do, I'm not sure if this is compressed or not, but yeah, so if you look at this file, it's got a structure that has, you know, an ID for the number, for the movie, and what category it's in. If you look at ratings, we've got different user ratings, a user, an ID number, a rating, and then like another ID. If you look at the user's file, it basically gives you the user ID, whether they're male or female, and some other kind of numbers. And you can look at these schemas to actually try to determine which columns from my data are important, which ones aren't, which do I need to use for this task that I'm going through, which do I not need to use. And you know, sometimes it's best to throw most of your data at it and then pull out what you don't need, or you can take the other approach where you put in just the IDs and then kind of we'll iterate on that. And that's kind of part of the Agile process as well.
So let me give you an example how this might be used with different type of data. Who here does a lot with web analytics? Anybody? No? Well, with web analytics, we do this a lot. You can actually use this recommendation system and jerry-rig your data into this to get an understanding of what users would most likely like or hit or go to a different page, if you will, or hit a different ad. You can do this type of thing. The data set's different, but with feature engineering, meaning some of the columns might be similar in terms of use to figure out, well, I have a list of clickstream data that tells me stuff about you particular users. I don't know who they are, but I have some information about them. I can use this recommendation system, otherwise known as an unsupervised learning system, to get an understanding of what would they be recommended to against the data set that I have already. So this is very similar in fashion to other types of problem sets in the industry. That's just one example.
Okay, so then at this point, we've unzipped the data, and now what you can do with Spark is run stuff right off of S3. Since you've got an EC2 instance, it can talk directly to S3. A lot of your data is not going to come from S3. So what we did for the purpose of this demonstration is we copied it from S3 as if we got it from somewhere else, and we're going to put it into Hadoop. So this command right here, basically they give you what's called ephemeral HDFS, and you can just use that to put that whole directory right into Hadoop. So if you run that, that should work. And to make sure that it works, we put a little hint. Make sure that if you run this, like a little ls, that you can see it on your cluster. So if we do an fs ls/data, we should see that we have our data there. If we follow through to here, you'll see that you have all of your files sitting cleanly on HDFS. Now, so this data is also not super huge, but it's just kind of, we took a smaller set so the Spark jobs would run in less than a minute and not, you know, maybe minutes or hours.
I think it actually still takes like
Or
2 minutes.
it might be 2 minutes, we'll see. So now that this ticket is done, what you would do is actually, you know, on a team, you would drag that into, you know, the done pile. But just to kind of keep going through, we have the data loaded into the cluster. We verified it's there. Now, we have, so we have another file that we need to take off of S3. So if we take this off of S3, what we can do is, it's this file, and we'll see what the download is. In an ideal world, you would have, you know, command line tools working, what have you, but
I know they won't change it on you.
yeah. So then now we've got this in our home directory, machine learning .zip. You can do an unzip on that.
Also put the command back in
Yeah.
trouble. Are we pivoting well enough for you guys? Given the environment?
This actually can be camera hidden somewhere. You know?
Exactly, it's right there.
Oh, I'm just waiting. Ashton Kutcher. So then, now we have this unzipped. This was the example that we actually pulled from the Spark Summit, where they were doing these examples. And if you look in the machine learning directory, there's basically the whole solution. And what we do first is to get your own personal recommendations. This is a Python script, rate movies, that will ask you questions about some movies you've watched. If you've seen them, if you could rate them. It's a pretty quick script, and then what it does is, that is the input to the Spark job as well as the actual data. And what it does is takes your recommendations, trains a classifier, it's called...
It takes the ratings of all the users.
Yeah, it takes the ratings of like all the users or whatever subset that you're using, and uses an algorithm called alternating least squares to basically try to fit a model that would recommend you something. We're not going to go into the nitty-gritty of that there, but if we do run this script, it'll tell you, please rate the following movie. So do we want to see what everyone would get collectively, or I could just go through it too?
Just go through it.
I think Toy Story was like pretty awesome. I'll give that a 5. I didn't see Independence Day, don't give me any crap for it. Dances with Wolves, didn't see. Star Wars, also have not seen. Mission Impossible, also have not seen.
He said don't give him crap.
Don't, yeah. I mean, yeah, you can.
You haven't seen Star Wars?
I haven't. I didn't see Die Hard. Batman Forever I saw, it was pretty sweet. Pretty Woman, it was actually on yesterday, I don't know if anyone saw it, but you know, I'll give it a 4. Men in Black, Will Smith, he was pretty solid, I'll give that a 4. Dumb and Dumber, I don't know, I like Jim Carrey, but it's kind of stupid. And then that's it. And what you'll see from here is that this has generated something called personalratings.txt. And if you look at that, it basically has some column, some movie column, and then my ratings. So if I rated it, or 0. And then what we do from here, basically, you know, you rate the movies, you have that. This is user ID, movie ID, rating, and timestamp. So if you see here, some of the ratings might be missing. They're separated with 2 columns.
Those screens kind of cut off as well. So.
It also looks like what they do is they might like regularize it, so that if I didn't rate a movie or I haven't seen it, it might give it an average of what I had rated it, just to kind of give it some weighting. if you give too few inputs to the system, it might just spit out total garbage. So
That's
when-
the secret behind machine learning.
yeah, you need to have enough prior data and prior knowledge to actually make an accurate recommendation. But then from here, you've got this next ticket for running the actual script. And like I was showing you before, you can submit jobs through Spark Submit. So you have Spark Submit right here, and you can actually pass through. You can actually pass through a Python script that has a Spark context object.
Now in the Python file, it's actually using the APIs for Spark.
Yes,
That's
so,
key. It's key to understand that.
So just to actually, step through I won't step through too much of the code if we're low on time, but if you look over here, I don't suppose syntax will work. Okay, so basically you import Spark config and a Spark context and the ALS algorithm. And if you look in the main down here, you'll actually set up Spark conf, give it a name, how much memory to use. It uses 2 gigs by default. You declare the Spark context with your config. It'll load your ratings into file. It'll parallelize that, so it's loaded in memory, good to go. And then from there, everything should be all good, and it'll print out the ratings once it's done.
One of the key things that you could test with, you can run Spark locally on your machines. You should run this once on your local machine, or a couple of times. And if you know Python, you can basically do a diff on time to show you exactly how long it will take on running on your box. Then run it in the cluster and do the same thing with deciding how long, calculating how long it takes. You're going to see the power behind using a cluster. You're going to see at least an order of magnitude much more quick, even if you have a very powerful box. If you have small data, probably not going to make much of a difference between the two. If you have large sets of data, it's going to make a big difference, and B, you probably can't crunch through all that data in terms of hundreds of gigabytes or terabytes on your local box.
Oh yeah. Python. So basically, Spark Submit will, as its first argument, take a job. Think of it as kind of running Python just as is. So we'll run the solution here.
And all this comes packaged with our download, or is this just specific?
This is specific here, but the
You can
Spark
write your
Submit,
own then.
yeah, the Spark Submit is there, but you can write all of your own jobs just using the Spark context and Spark API in Python. And then as you would run a script, like if you run Python movie.py, then you can pass all of your arguments afterward, like where the data is, it's like, is it local, HDFS, S3, and any other arguments you have. So for this particular example, if you looked in like the sysargv that we kind of have, you give it the script, and then after that you give it where it is on HDFS. So that's just the protocol for it. Followed by your actual personal ratings. So yeah, the HDFS data is the training data that generates the classifier for ALS, and then over here we would have our personal ratings, and hopefully that'll work. Nope. Murphy's Law again. Unknown host. Unknown host. Oh, here.
There you go.
Hopefully that works. So this is all part of the debugging process, trying to figure out where the stuff is.
Did you put a space or something?
Okay, so now it's actually running, and you can actually monitor the process with the IP address. So just to show you, let's see. So if you go to your EC2 instances that you have running, you see you have the Spark master over here, and it's got a public IP address. And I believe it's this port that has Spark running. Might be. Yeah. So it'll show you here what's actually running on your cluster right now. How many gigs of RAM you're using per node, what you're kind of doing with everything, how long it's been running, and you can see how that works. So if you look through there, it's going through a lot of these memory blocks very quickly.
Maybe we'll take questions while it's doing things.
Yeah, so does anyone have any questions up through now? I know I just covered a lot. So if everything works, when this is done, it'll give me a list of a couple movies I should watch, and
50 movies.
Yeah, 50 movies, and we could step through a few. I'll tell you if I've seen them or if it's any good. And when you're actually working on a machine learning problem, you can sometimes test on yourself or on a small subset of users or something. A/B testing. You might be at a bigger kind of company, but a good way to validate if something worked is you can look at what it recommends you. Would I watch this? Have I seen any of these? Maybe look some of these up.
And then another thing you typically do in machine learning is you separate your sets so that you can train on some of the users or some of their data, and then you can see if it actually recommends things that they watch.
Okay, so if you look over here, these are the movies it recommended. You could look over here first and see that this took 1.8 minutes to process the 1 million rows, train the classifier, and then once it's trained, it's usually very, very quick to evaluate based on your user input. We didn't give it too much. The hard part was really running the ALS algorithm to generate that classifier. So now, if we step through these, okay, I haven't seen Bandits, but Shawshank Redemption, that's awesome. That's at the top. I would totally see that. I haven't seen Star Wars. Maybe I should watch it. Schindler's List. I'm Jewish and I can appreciate a good historical piece, so I would watch that. Some other ones. Toy Story 2. I saw Toy Story 1. Why would I not like Toy Story 2? It's a Wonderful Life, real classic. So you can kind of play around with this data and see what it recommends you, recommend it on someone else, and play around with it, see what columns it's taking from the actual features, and then kind of go from there. So in the context of Agile, there's a big, with iterating and pivoting, you can kind of take these results and say, this is totally garbage, what should we do next? Let's trash it, or let's move on from here. Or this is good, why don't we put a front end around it and actually let people run their own? And the different business requirements and different ideas you have can help you kind of pivot and go from there. Does anyone have any other questions? Yeah.
The user, when it asks you to rate the movies, is that random or is it always the same?
In this case, the example code we pulled, it's always the same movies, but you could easily kind of look through the data you're given and write a different script that'll maybe pull a random subsample. Because if it's the same movies you ask to everyone, it might not be, it might be a biased kind of questionnaire. This is definitely not meant to be perfect, and the kind of iterations will help you improve that. In probability machine learning, you want to use a more random subsample and possibly a larger one. You had a question?
I just wanted to know, where did the example come from? Was it the one that actually won the competition?
It wasn't, no. So this was just a small example of how to use Spark to do something with movie recommendations. This came from Spark Summit. We kind of
Last year.
Yeah, from 2014. The actual prize, I'm not sure who won or why they won, but I'm pretty sure the algorithm they used was collaborative filtering. And the basic idea behind that, I won't get into too much nitty gritty, but it's basically you have, one person that watches these 5 movies, one person watches these 5, they have an overlap of maybe 2 or 3, and you can kind of use these big diagrams of the overlaps of different users to kind of filter movies down to a subsample that a certain group might like. So, you know, you can really dig into the theory too, instead of just knowing, okay, you know, the regularized ALS algorithm works really well, I'll just throw the data in here, get recommendations. You can actually, you know, take whole courses and get PhDs in this kind of theory for actually coming up with this and, you know, changing things. Anybody else have any questions? Bueller?
Cool. Where are we on our board? We're complete?
That's it. That was pretty much it. We were gonna kind of ask people to maybe change stuff afterward. The last kind of task was to maybe edit and, you know, change different functions in that solution.
Okay. So what we'll do is we have everyone's email address, right? The names. You sign up here. So what we'll do is we'll actually create a. Actually, would you recommend just putting this into a public GitHub and just allow them to use it, or?
Yeah, so what we'll do is over the next couple of days or so, we'll get everything onto a GitHub, and with all your emails, we can give you a more central access to this data.
Right.
The reason why we kind of spliced it between S3 and all these locations was because we weren't sure how good the internet would be. So we wanted the EC2 instances to pull right from Amazon and not from GitHub, because if you have 20 or 30 people all trying to pull from GitHub at once, that could, you know, cause a ruckus.
So what we'll do is we'll provide this information for you, and you can run through it on your own. And what I would like to ask is that you would, on the seminar right up there, if you can right now on your computers, just fill out that seminar survey, and it's anonymous. And we just want to know what your feedback is on it, and we'd also like to know if you do want this course, and we'll actually can reach back out to you. We won't know you specifically, but if you are really interested, without even after filling out the survey, just email me. Actually, email Fred. Okay. Fred at thehackerati.com, and express your interest. And what we're looking at, as you can see in the survey, is basically, is it a intro course, or you want something more advanced? And we're going to be doing it in collaboration with TurnToTech. So I want to thank very much.
You see a set of different possible courses, also some different methods, like whether it's a once-a-week thing or like more intense, many days, one after the other. Just get some feedback as to what you think the best venue would be for you.
So can we get this presentation back to all the way? So there again is the link. I want to thank you for your patience. We did start about 15 minutes late just for logistic reasons, and we'll take that into account moving forward. We hope that you enjoyed the pizza from my ancestral homeland, Italy. It wasn't literally made there. It was made from a friend who actually comes from Naples, Italy. And we hope that you enjoyed the seminar, that you learned something, that you took something away with you, and hopefully it was attractive enough that you'd actually want to take a full course in this. Again, I want to thank Ethan and Derek for their hard work in putting this together. And I also want to thank TurnToTech for sponsoring, as well as, I know the Amazon guys left, John and John, for their sponsorship, as well as my friend Andrew at Big ML. And we hope that you will come to one of our classes and also one of our next seminars on additional topics. And one of them perhaps may be a specific on how to build something with big data as a use case, and also maybe some in detailed machine learning. We also do have a whole bunch of other types of courses that you'll see in the anonymous survey, that if you respond to that, then we'll be able to craft something moving forward. Again, I want to thank you for coming tonight. It's always a wonderful opportunity to teach something that we know and love each day, and that we actually do this with our clients every day. And if you want to know a little bit more about the Hackerati in general, you can see Derby, our head of talent, or ask any one of us who, now raise your hand again for Hackerati if you want to come and talk to us. Thank you and have a wonderful evening. And